So let's get started with Java. So our starting point is a famous reference which comes from a book by Kernighan and Ritchie, which is a very well-known book, Introduction to the C language, almost 50 years ago. And in this, they suggested that to learn a programming language, you really have to get started with it, right? So you need to do something, and what's better than to get the program to say something. So they came up with this iconic hello world as the first message you should be able to print from your programming language. So they said that the first program you should always be able to write in any language is hello world. And if you get over this, if you are able to actually somehow edit this program, save it, compile it and run it, you have overcome the first major hurdle to learning programming, which is to get the mechanics of running a program right. And once you get over this hurdle, then everything else is easy. So be that as may, this has become a sort of a symbolic challenge to see how easy or difficult it is to program in a given language, which is how difficult is it to put out a program that does hello world. So the language that we have been seeing so far in this program, in this course, has been Python. And Python is particularly good in this respect because the simplest Python program for hello world is just a single print statement, right? It just prints hello world. One line, can't expect to do anything less than that. And this is what makes Python for many people a very attractive language to start programming. There is not a big syntactic barrier to starting to write code. In C, which is the language which Kernighan and Ritchie were themselves teaching in that book, it's a little bit more complicated. So one thing is that you need to make this print statement available. So this is the equivalent of an import statement in Python. So the C programming language doesn't have print available by default, so you have to include the standard input-output library. The other thing is that C, everything has to live inside a function, so you have to create a function for this. And by convention, as we will see, the function that you start running is always called main. And finally, you have the equivalent of the Python print statement, except it's called printf. And the other thing is that you have to explicitly put a character called new line to make it print and go to a new line. So this is already a little bit more complicated than Python. And now let's look at the corresponding Java program which does this. So this is really quite scary to look at. Okay? So buried inside it, you see this much, which looks familiar. Right? So you have a print statement which takes as argument the string hello world. So presumably that's the job that we are doing. Now, like C, it is enclosed inside a function definition. Unlike C, which just has main, it has a lot of stuff around this function definition. And certainly unlike C, it has a further layer of complexity because we actually have put it inside a class. Okay? So why should we need a class to print a string? So let's try to get into this complex definition and understand a little bit about why all this machinery is there. And though it is of course not going to be possible to explain all of Java with respect to this toy example, it will give us a good idea of the kind of things that we will encounter as we go ahead. So the first thing that we have to do when we unpack the syntax is understand why there is a class out there. So why is this class definition here? So remember that Java is designed bottom up as an object-oriented programming language. It came into being with the philosophy that it would be object-oriented. In an object-oriented language, as we remember, we define functions in the context of objects. Right? We don't write functions to which we pass data. We create data on which we can apply functions. We send messages to objects. We tell an array to sort itself, for example. So therefore, every function in a truly object-oriented language has to be sitting inside a class. It has to be defined only in the context of an object. We cannot have free-floating functions sitting out there because we are not supposed to be passing things to functions. We are supposed to be invoking functions on objects. So every function must live in a class, so must this one. And therefore, we have to create a class for it. Right? The other part of it is that we have to know whether this class is available or not. So remember that we said that in the Python implementation of objects, there is no distinction between public and private. So even though you have encapsulation and things are kind of modularly written, there is nothing to prevent you from going inside and adding a field or modifying a value and so on. Now, Java takes object-oriented notions very seriously, so it tries to separate the public and the private quite clearly. And this has to be done by declaring what is public and what is private. So clearly we need to execute this function inside the class. So if the class itself is not public, we cannot execute this function. So we also have, in addition to the class definition, we have this extra modifier, as we could call it in Java, saying that this class not only is there, but it exists only for the sake of defining a function, because we cannot define a function without a class, but this class must be public. So now we move inside, and the next thing we encounter is the function itself. So like in C, we need to create a function. Now why do we need to create a function? So remember that this is not a language which we are going to interact with. So when we are writing Python code, very often we are interacting with it through something like a Jupyter notebook. And if we are not interacting with it, we call Python as a standalone program, then it just goes down, because not all Python code has to sit inside a function. So you can just write Python programs, which is a sequence of statements. So Python will just take a piece of Python code written in a file and execute statement by statement from top to bottom. If they are function definitions, it will understand the definitions. If they are not definitions, it will try to execute them. So there is no problem with a Python program. You just give it, it's a sequence of instructions. The instructions may be function definitions, they may be actual statements. You just execute them top to bottom. But if you have a language like C or Java where everything must be inside a function, then you cannot just start executing because you don't know where to execute. So where do you start? Because everything inside a function, which function starts? So there has to be a convention, and so C actually began this convention that the function which begins everything, the thing that kicks off the whole thing, is the one that is called main. So there is one special function called main, and all execution starts there. So that's why when we defined this hello world in C, we had to create a function called main. So Java inherits the same convention, so to speak. So in Java, all execution starts in main. So that's the reason we have a function called main. So we have to write the function inside a class, but we have to have a designated function to start with, and that is main. Now, the next part is what is around the main. So what's inside the brackets and what's just before main. So this is the so-called signature of main. Right? So with every function, it takes a certain kind of arguments and it returns a certain kind of return value. Now you might think that a function like main, which is called from nowhere because it starts off on its own spontaneously, as it were, nobody's there to pass it any arguments, so why should it take any arguments? And similarly, it's certainly not going to return anything to anything that called it because it's not being called by any function, so there's no return value. So the fact that there's no return value is clear, so the return value is the one that is outside the function. So with Java, it's not optional. You always have to provide the return value. So if your return value is nonsensical or it doesn't exist or whatever, then you use the special type called void. So void means empty. So void is a type which contains no values. So void is essentially the type equivalent of a Python word like none for a value which does not exist. So here it's saying it's a type. A type is a collection of possible values and operations on them. So void is an empty type. It has no values. So the value returned by main is of this type, so therefore it will never return anything. That's what it means. This part is a little bit more complicated and we may or may not look at it in more detail as we go along, but though you cannot of course call main with any arguments because you're not calling it from inside another piece of Java code, when you call it from the command line, you can pass arguments through what are called the command line arguments. You can write the Java program name followed by certain other things, and these other things will be implicitly passed as arguments to main. So this is now, if you, as we go ahead, we will see that this stands for an array of strings. So we write the name of the program and then we write a sequence of words after it. Each of them is passed in turn as an argument, and that's all. So this void and this string array called args are the signature of this function, that is the input and output type. Now, just like the class has to be public or private, the function has to be public or private, and obviously we want to execute this, even though we are not executing it directly, somebody has to execute it. So it has to be executed from outside the class, and therefore it must be public. Right? So that's why we have to announce that this function is public. Now what about the static? What is static doing? So we are in a peculiar kind of catch-22 of our own making. So remember that Java has decided, because it is object-oriented, that every function must live inside a class. Now how do we invoke functions on class? We have to create objects, right? So we remember that in Python we created this class called point, and we defined a function called translate, which would take xy and move it to x plus dx, y plus dy. Now obviously we cannot call translate until we have a point, because there is no function translate on its own. It only exists in the context of one point or another point. So we have to create an object in order to invoke the function. Okay? Now here we have a function because we have put it inside a class called hello world. So we have to create some object of type hello world in order to invoke main. Who's going to create that object? It has to be some code, but which code is that? Nothing is running. Okay? So we have this catch-22 as it's called. We have this circular thing where we need some code to kick off main, and we need main to kick off the code. So clearly you have to break this cycle somehow. So that is broken by this modifier called static. So static says that this definition that we have here inside a class is actually not tied to any object of that class. Right? So here it is a function. So it says that this function is, you can think of it, it is more or less like a normal function. So this is like a function that you would find in Python outside with the def statement, which exists independent of whether you've created objects or not. Except that here it is defined inside a class and then kind of artificially made into this category by giving it a static modifier. So static says this function can be invoked without having to create an object of that class. Many other functions that we can think of will behave like that. For instance, here we have one already which we will come to when we do it, the print statement. You don't want to create an object to print, but even the familiar math functions, right? If you want to do sine, cosine, square root, and they sit inside some library. Now in Java, that library would be a kind of a class. And do we want to create a math object before we can use that? No, we would like to be available. So this idea of having static objects, static functions, static values will be important to us. So that takes care of the two outer lines of code in this program. So now we come to the actual function. So here we can see that deep inside there is something which looks similar to what we saw in Python and what we saw in C, which is a print statement which takes an argument and prints it. But remember, in Java, this print statement must live in some class. It can't just be on its own. So that class is called system. So that's why we have to put it with respect to system. So the syntax here is similar to the Python thing where we use libraries. So remember, in Python you'll say things like math dot something, math dot square root, right? So you would say that this is the function square root which is inside the library math. So here instead of a library it's a class. So this is the function println inside the class system. So that's what the system is telling us. So system is a public class which contains this print function. But the print function is not again a function which can be applied in general. It has to print somewhere. So in Python, for instance, when you do file input and output, then what you have to do is you have to associate what's called a file handle. Right? So you connect your program to the file through kind of a pipe, and you write or read from that pipe, and then the system outside has to do the job of converting what is in the pipe into something on the disk and vice versa. So you don't directly read from the disk or write to the disk. So you can do this in an abstract way by dealing with these file handles. And if this file handle is not really going to a file, but it is going to a kind of coming from the keyboard or going to the screen or something, then this is called a stream. So out is a stream, right? It's a stream of data which is going out somewhere. So the Java program just sees us as a pipe where it will write out data. And what this is saying is that we are printing with respect to the particular pipe called out. So out is a specific stream which will feed, in our case, typically to the screen on which we are viewing this Java program. So remember that this out is an object in some sense, and it exists because we have not created anything clearly. In this code, there is no line which created out. So out must already exist, just like main already existed. So out is also some kind of a static object. So out is a stream object which is static and defined inside the public class system, and we are invoking println with respect to this particular stream object. So finally we come to println. Well, it's just a print statement. Now in Python, print says print with a new line, and if you don't want a new line, you have to pass an extra argument. In C, printf does not put a new line unless you pass an extra character. If you go back and look at that code we saw before, there was this \n that we added at the end of the string to print a new line. So Java, it turns out, has two different functions. It has a println and a print. So the print will just print what it's given to it and stay on the same line. Println will go to a new line. So otherwise there's nothing very complicated. So at its core, this is the same function. It just is wrapped up in all the syntax. Now there is, of course, with respect to Python, one more level of difficulty in syntax which we have not seen before, which is all this punctuation. Right? So in Python, we write def something, right, and then we put a colon, and then we indent our code, or we write for something, put a colon, and then we indent our code. So there is implicitly a notion of a block of code which is tied to that for, or a block of code which is tied to that definition. So how do you demarcate the beginning and end of this block? In Python, this is done by layout, right? So you indent, and everything which is at the same level of indentation is part of that block. And once you go out of that level and come out to a higher level of indentation, the block is over. So you have to be very careful about how you lay it out, but the advantage is you don't need any other kind of markers to indicate the beginning and the end. Now in most programming languages, this is done syntactically by using markers, and the normal way of marking it is to put an opening and a closing bracket, or a brace especially. So this is the opening brace. It says that this is the block of code defining the class begins here, and the matching one is here. Okay? And then inside that there is a function. The beginning of the block defining the function is here, and the end is here. So you use explicit begin and end brace. Right? So these have to be matched correctly, like all brackets do in any expression that you write. In arithmetic also, you would have to match the brackets properly. You can't intersect brackets, right? But you have to match them, and for every opening brace there will be a corresponding closing brace, and that denotes a block of code. So the block of code could denote, in this case, the body of a function, the body of a class. It could denote, like for example, the scope of a loop, or the scope of an if, or the scope of an else, as we will see. So this is compulsory. And the other thing which is compulsory in Java is that every statement must end with a semicolon. So this means, of course, you can write all of your code in one line, because now the layout is not important. But then, of course, it will become unreadable. But in principle, you can write a Java program as you wish. Right? A new line has no real significance in laying out a Java program, unlike in a Python program, nor does the indentation. So the choice of indentation and where to put new lines is more a question of style as far as the programmer goes for readability, but it's not required for understanding the code from the compiler. Whereas in Python, the layout is crucial to understanding the code. So there are trade-offs. It's much easier to read Python code if you don't have all these braces, but also it's a little tricky, because sometimes if you accidentally get the indentation wrong, or if in the process of transferring the file from one person to another person and back, the spaces get changed a little bit, then unintentionally you might end up changing the meaning of the program and not realizing it until later. So it's a source of bugs also. So it's a question of whether you like it or not, but almost every programming language other than Python will actually use braces and semicolons to delimit blocks and statements. So that deconstructs this program. So we have this program, what do we do with it? Okay? So in general, as we said, everything in Java has to be written inside a class. So therefore, a Java program is a collection of classes. Right? So how does Java keep track of this? Well, what Java says is that each class must be in a separate file, and the name of the file must match the name of the class. So here we have chosen the name. You can choose any name you want. So we have chosen the name Hello World for this class, and that means we must put it in a file called Hello World with an extension .java. So the extension .java is compulsory. It tells us it's a Java program. But what we write before the dot is exactly the name of the class. So the class name inside and the class and the name of the file should match. Otherwise, Java will get confused. Okay? So we put the class Hello World in Hello World Java. Now, eventually this will run, but where will it run? So when we use languages like C or C++, of course we compile them. So that's why we said that when we compile them and we run them, we are not interacting with them. So we have to use some convention that they start with main and so on. But the important thing is that they're running on the hardware that you are using. So if you are running it on, say, a Windows machine on an Intel CPU, or if you're running it on a Mac on an M1 chip, or if you're running it on a Linux machine on an AMD chip, the underlying architecture and the machine language is different. So you start with the same high-level language, but your compiler will produce code for the given architecture. Now, usually these architectures are similar, but sometimes there are some subtle differences. So code that runs properly on one machine may or may not behave the same on another machine, and this used to be even more problematic 15, 20 years or 25 years ago when Java came into being. So Java is roughly from the mid-1990s. So it was created in a scenario where there were frequent bugs resulting from the fact that code which was tested and verified on one system would not run in a different operating environment. So the solution that Java came up with is to produce a uniform environment for running Java code. So they said, let us not think of Java code as running on this machine or that machine, but it's running on an abstract machine which we call a Java virtual machine. So Java code is designed to run on an abstract virtual machine, and this abstract virtual machine is then implemented with respect to different architectures. So the problem of implementing on the architecture is restricted to the virtual machine. You have to make sure that the virtual machine instructions are converted to the local machine instructions once and for all. Now each individual Java program is written in terms of the virtual machine. So then that part of it will work on any implementation, because all the virtual machines are supposed to behave the same, whether the underlying architecture is running on one operating system or another, on one chip or another. So this JVM provides a uniform execution environment, right? And it also allows us to give a uniform semantics for Java. If somebody says, what is the maximum size of an integer in Java, you don't have to say, oh, if it's a 32-bit architecture, it is this, and if it's a 64-bit architecture, it is that, and so on, because the JVM will decide, right? If the JVM is 64-bit JVM, it is so much. If it is 32-bit JVM, it's so much. It doesn't matter whether it's running on this chip or that chip. So it is OS independent. So in fact, one of the big slogans when Java was introduced was write once, run anywhere. And this was particularly important because it also coincided with the time when the internet was getting more popular and people were writing code which would run on different machines and transporting it across and so on. So it's also a need for running code in different environments. So it was born out of a necessity, and it is a very useful thing to have in general, that Java code is portable. So we still have a machine. Right? It's not the machine on which we are actually working, but there is a layer on top, this JVM. So our Java code has to be translated into that machine. So we still need a compiler. So this is called Javac or Javac. So Javac compiles your Java file into what is called bytecode. So this is very similar to any compiler, but instead of compiling it for a specific machine architecture, it's compiling it to this hypothetical virtual machine code. So this is called Java bytecode. And this will sit in a file called hello world.class, right? So now this dot class, so we started with hello world.java, and Javac will produce as output bytecode, which it will put in the same class name but with an extension dot class. Now this is a little bit confusing, but this class has nothing to do with the object-oriented class. It's just it could have chosen any other name. It could be called cake, or it could be called butterfly, or whatever. But they happen to choose the word class. Okay, so your Javac will take something in a file .java and will produce it in the same file .class. So this is now the code that will run, right? But you have to run it. And how do you run it? Well, you have to invoke an interpreter. So the interpreter is called Java. So Java running on this class file will run it on the JVM. So you need a JVM installed on your machine, right? And there are JVM installations available for almost anything. You have to search and download and install Java development environment, as it's called, a JDK, and you can run it. Okay? So Java Hello World will run this bytecode, and the promise is that this will run the same on your JVM as it will run on any other JVM. So you can take in principle this .class file and run it anywhere. You don't have to take the source code and recompile it on another machine. So there are some minor irritations with this whole thing. So one thing is the way that you call. So when you use the compiler, you must of course call it on a file which has a .java extension, but you must pass the extension as part of the command. So you must say Java hello world.java. You cannot just say Java hello world and expect it to find hello world.java. I don't know why. It should be easy, but it is part of the design. Now it will produce this .class file, but Java, the interpreter, will not allow you to say .class. You have to say Java hello world, and then it will look for .class. Okay? So this minor, so for the compiler you provide the extension when you call it. For the interpreter you do not provide the extension. The other potential problem is this business of having different classes for different files for different classes. So remember that in Java everything must sit in a class, right? And every class must sit in a file of that name. So you can't put 20 classes in one file because the class name must match the file name. So every class is a separate file. So if this were required that we must compile every class separately, then it will be very tedious, right? If you are using 10 or 20 different data types or various objects in your types of objects in your code, then each time you compile you have to sit and meticulously compile all of them. Fortunately, that's not required. Remember that this main is the starting point. So among all your classes, there should be one which defines a main. So that's where things are going to start. So Java, the compiler, is invoked on that class. Now inside that class, you might define objects of other classes. So this is where Java uses the fact that the name of the class and the name of the file match. So if you suddenly say that I have defined a point inside this particular function main, then it will go and look for a point.java, because the class point must be in a file point. Now if point.java in turn uses some other file, then it will go it will go and look for that file. So by following the chain of classes, now how do these classes come about? Remember, everything is declared, right? So you have to declare that I have a variable of type point, I have a variable of type color, I have a variable of type that. So for every declaration that Java finds in your code, right, it knows that that corresponding class file must also be compiled. So Java compiler is smart enough to follow this chain of dependencies and compile everything that is needed, and if something is missing, it will tell you. So fortunately, though you have to keep track of these different files, one per class, you don't have to manually compile them. They get compiled automatically. So what we have seen is that compared to Python certainly, and even compared to what little we saw of that example in C, the syntax of Java is quite heavy. Right? There's a lot of baggage which seems to be there in the way of writing even simple code. But unfortunately, this is a byproduct of the design choices that have gone into the language itself. So it's a purely object-oriented language, and it wants to clearly maintain this public interface versus the private implementation idea. It wants to make sure that programming is disciplined without having to rely on the programmer's discipline. So you want to make sure the compiler can enforce its discipline. So you need these modifiers, public and private. You need to create objects, you need to have functions available before you create objects, so you need these modifiers like static and so on. The other thing is that, like languages like C and C++, you need to declare functions and variables in advance. So this helps in two ways. One is, as a programmer, it helps you from making mistakes, and for the compiler, it makes it easy to keep track of storage and what kind of values to use and so on. And finally, the selling point of Java is this write once, run anywhere. Right? So Java is designed to be a portable language. So it is defined in terms of this virtual machine. So Java compiler creates this bytecode for this virtual machine, and this bytecode is guaranteed to run in the same way across architectures. So you have portable code.